Hi Pre-Calc, welcome back. Hope y'all are well. Today's objective is going to be to apply properties of logarithms. I've got the checklist on the screen. You know what to do from here. So before we get started with properties of logs, I want to review properties of exponents, since logs and exponential functions are inverses of each other. So not surprisingly, their properties are going to be inverses of each other. So I'm going to force pause on the screen. Can you go ahead and fill in the review problems for me? Hit continue when you're ready to check your answers. All right, I've got answers on the screen. Go ahead and pause if you need to change anything. All right, I'm going to need you to pause your own screen here and copy the table that I have, leaving this third column with blank with some space for us. So go ahead and pause for me. Okay, hopefully you paused. So we're going to fill in this table. So log base 2 of 8 is what? It is 3. Because 2 to the third power is 8, right? Remember, log always reveals the exponent. And log base 2 of 4 is what? Is 2. And 3 plus 2 is 5. So can you figure out what should go in here? So log base 2 of what is 5? So that's going to be 32. Because 2 to the 5th power is 32. Remember, this is your power of this base. All right, let's try another one. So what is log base 3 of 9? That's 2. And log base 3 of 3 is 1. So 2 plus 1 is 3. And log base 3 of what is 3? Well, that would be 27, because 3 to the third is 27. Okay, are we seeing any patterns? I'm going to force a pause on the screen. You've got this written down. See if you can come up with the remaining 4 blanks for me. Hit continue when you're ready to check your answer. All right, I've got the answers on the screen. Have you been able to spot the pattern? How do I go from 2 logs with the same base to just 1 log with that base? Well, if I've got addition between the 2 logs, I just multiply what's called their arguments, okay? So 5 times 1 is 5. 1/9 times 81 is 9. 9 times 3 is 27. 8 times 4 is 32. So in general, let's put one more row on there. If I have log base b of m plus log base b of n, I can make this into 1 log by multiplying the insides, okay? Now, again, this shouldn't be that surprising because remember, for exponentials, when you multiply the outsides, you add the insides. Because for exponentials, this would be the outer function, this would be the inner function. So the opposite is true for logs. When you add on the outside, you can bring it in by multiplying on the inside. Voice pause on your screen, can you go ahead and copy example 1 for me? All right, we are going to use product rule to expand and simplify if possible. So here I have multiplication on the inside. So remember, I can expand that into 2 logs using what operation in between them? Addition. So this is the same as log base 6 of 7 plus log base 6 of 11, all right? First pause on the screen, can you go ahead and try the next one on your own? So again, we can separate those two to log of 100 plus log of x. Now remember, the understood base here is 10, so this can be simplified to 2. So I can rewrite like so. All right, so that was product rule for logarithms. Not surprisingly, there's an analogous quotient rule. So remember that for exponentials, when you divide on the outside, we can bring these into 1 by subtracting on the inside. So the opposite's true for logs. If I subtract on the outside, I can bring these into 1 log by dividing on the inside. So I'll force a pause on the screen. Can you go ahead and copy that? All right, so notice that for product rule, multiplication on the inside turns into what on the outside? Addition. So then that's how you can break them into more pieces by putting a plus on the outside of each log. Quotient rule has division on the inside, and it turns into subtraction on the outside. Force a pause on the screen. Can you go ahead and try example 2 for me in your notes? Hit continue when you're ready to check your answers. All right, I've got answers on the screen. You can pause if you need to. Keep in mind that this first term here does simplify to 5, so I can put ln of 11. All right, so we've got one more rule. It's called the power rule. So remember for exponents, if I raise a power on the outside, I multiply those on the inside. So the converse is true for logs. If I raise a power on the inside, I multiply that number to the outside, okay? I think of this as flying that exponent here to the front, okay? Now this exponent has to be inside, remember, inside the argument. And if it is, then I can fly it as a coefficient to the front of that log. All right. So let's try example 3. I'm going to force a pause on your screen. Can you go ahead and just copy what I have for example 3, and then we'll do them together. All right, so I see that I have a power on the inside, so I can fly that to be a coefficient on the outside. And no pun intended, but this rule is going to become our most powerful rule when we start to solve log and exponential equations, okay? So I have that as my final answer. What about here? I'm supposed to use power rule, but I don't see a power, so what could we do first? So first, I could keep this ln, I could first rewrite that as x to the 1/3, right? Then I'm going to take that 1/3 power, fly it to the front, so I've got 1/3 ln of x. Force pause on your screen. Can you go ahead and copy my screen and fill it in? So can you recap our 3 rules? Hit continue when you're ready to check your answer. All right, I've got answers on the screen. Go ahead and pause if you need to correct anything. Force a pause on your screen. Can you please copy example 4 for me? All right, so example 4 says we're going to expand as much as possible. So first of all, I see an x and a y with multiplication on the inside. So that's going to turn into what on the outside as I break them, as I expand? Addition. Okay, so I'm going to start by doing this. Log base b of x to the 4th plus log base b, and can I rewrite that root as a power y to the what? 1/3. Good. All right, now I can expand even more by applying power rules. I can fly that 4 forward and whoop, fly that 1/3 forward. So final answer, 4 times log base b of x plus 1/3 times log base b of y. All right, can you try the next one on your own? Hit continue when you're ready to check your answer. All right, I've got the answer on the screen. You can pause if you need to change anything. Notice that we have a division here, right? We also have a multiplication here, so I can break this into 3 separate logs, making sure that I have a minus in front of any log whose argument was originally in the denominator. All right, see if you can go the other way around. Example 5, condense into a single log. Go ahead and copy this and try it on your own. Hit continue when you're ready to check. All right, I've got the answers on the screen. Keep in mind I cannot cancel these x's, okay? This x is with the 7 and the 6, so pause if you need to change anything. All right, let's continue with that example. I'm going to force a pause on your screen. Can you just copy what I have, please? All right, so if we want to put these into a single log, this will be ln. Now first, let's go ahead and fly this 2 back to the exponent. So ln of x squared plus ln, and now I'm going to fly this power of 1/3 back to this exponent. So x plus 5 to the 1/3, or I could think of that as the cube root of x plus 5, right? So now I can condense this into a single log using what operation? Multiplication. So I'd have x squared times the cube root of x plus 5, or again x plus 5 to the 1/3 is the same thing. All right, can you do this one in one step? I'll force pause on your screen, hit continue when you're ready to check your answer. All right, the answer's on the screen. Go ahead and pause if you need to change anything. All right, first pause on your screen. Can you please copy what I have? So change of base property was something that was really handy dandy when we could not just type in any base into our calculators. So change of base says that if you have log base b of m, you can change this into log base a, where a is whatever valid base you want it to be, of m over log base, that same number, over b. Okay, so if I want to change log base 7 of 2,506, I can write this with, say, a base of 10. So log base 10 of 2,506 over log base 10 of 7. Okay, and this should be the same as, and if I chose a base other than 10 as well, like base e. So this should be the same as base as ln of 2,506 over ln of 7. Let's check it on our calculators. All right, so I typed them in the calculator here, and you can see that you get the same thing for both ratios. All right, first pause on your screen. Decide if these statements are true or false. Hit continue when you're ready to check. All right, so this one is true because we can rewrite this as log of 2 to the 1/2 power, and then by the power rule, I can fly that 1/2 forward. And multiplying by 1/2 is the same as dividing by 2, so yes, that is true. Now, this one, would we get true or false? This one is false because the whole point of these logs is to go from 2 logs to 1 or vice versa, so we should just have log base a of 14 times x without the second log. I do want to give you one little warning on the first 2 problems on MyMathLab, and it's only the first 2, where you expand into this, right? And most of us would say great expansion. Think about if this can be written as some base to some power, because 8 can be written as 2 to the 3rd power, and so then I can apply power rule and write it like that. Okay, so just be real careful. That's my only warning, and it's just the first 2 problems on MyMathLab. So maybe make a little note for yourself so that when you start MyMathLab, you remember that. All right, you all, I will see you next time.